Okay, guys, this is 4.8, pages 255 and following. I absolutely love 4.8 because it brings together all the things we've been doing: tables, ordered pairs, and graphs, okay? And it shows you how X and Y relate to all of those, okay? So let's just begin here, and I might break this up into a couple of videos. Equal ratios and graphs. How can you use a graph to represent equivalent ratios? Okay, so a car travels at a rate of 50 miles per hour. Right there is a unit rate. Okay, we've been talking about that. Use equivalent ratios to graph the distance the car travels over time. Graph time on the x-axis and distance on the y-axis. So you can see down here, this is your x-axis, this is your y-axis. Time and distance, that's down here. Time and distance, x and y. Okay, so let's go down through here. Use the unit rate to write equivalent ratios. So it says right here, 50 miles in 1 hour. So 50 miles times 2 would equal 100 miles in 2 hours, and so on and so forth. This is your chart. The top is your X, the bottom is your Y. I am sorry, that is not true. This is your X, this is your Y. Okay, they have reversed it, so Y and X. Down here they have the time for X distances, but up here so you got to be careful. So in 1 hour we go 50 miles. 1 times 50 is 50. Okay, 2 times 50 is 100. So in 2 hours we go 100 miles. 3 hours we go 150. 3 times 50 is 150. 4 times 50 is 200 miles. 5 times 50 is 250 miles. So we built out our chart, Y's and X's. This is your input, output. I don't like that they have it that way, but anyway. So use the ordered pair to represent each ratio. So it was 1 and 50. See how now it's your X and your Y. 2 and 100. 3 and 150. 4 and 200. 5 and 250. So these become ordered pairs also for graphing. Okay? The first number in an ordered pair is the X, and the second number is a Y. You should know that pretty well. Now we're going to use these to graph it. Use the ordered pairs to graph the car's distance over time. Think the graph represents the same relationship as the unit rate. So this graph is going to represent that unit rate. For every hour the car travels, the distance increases by 50 miles. So 1 hour, 50 miles. 2 hours, 100. 3, 150. 4, 200. 5, 250. And so on and so forth. We could keep going, increasing 300, 350, 400. Notice it changes at the same rate, 50 miles. That's why I end up with a nice straight line. That's called linear in a line because it's a constant rate. Okay, let's see what we got in the back here. Okay, this is page 256. Example 1. During a heavy rainstorm, the waters of the Blue River rose at a steady rate for 8 hours. So it's rising consistently. The table shows the river's increase in height over time. Use the graph to complete the table of equivalent ratios. How many inches did the river rise in 8 hours? So on the graph, the x-coordinate right here represents time in hours. Notice right here, hours. The y-coordinate represents the river's increase in height in inches. See how it's labeled? So you need to understand that, how things are labeled. The ordered pair 1, 3 means that after 1 hour, the river rose 3 inches. 1 hour, 3 inches. After 2 hours, the river rose 6 inches. Notice they skip. 4, we come up here to 12. Every time I'm multiplying the x by 3. 6, I end up at 18. 8, I end up at 24. So the river rose 24 inches in 8 hours. Okay, this was your x, this was your y here. Describe the pattern you see in the graph and the table. I would say something like the x's are the same, y's are the same. Consistent pattern. Well, how do we know they're equivalent? I'm multiplying by the same number. So times 3, times 3, times 3, so on and so forth. Okay, Matt earns $12 per hour. Explain how you could use equivalent ratio to draw a graph of his earnings over time. So I would say 12 to 1. So then I could say $24 in 2 hours, 36 in 3. I could multiply everything by 12. And I could just come here and I can go 1 hour, 2 hours, 3 hours. 12, 24, 36, 12, 24, 36. Okay. That's a tough one. Okay, that ends the lesson.